question, then I'll discuss this with you. Look, class, for this particular question, when we are writing, Two magnets are given, bar magnets are given to you. You have to find out the magnetic field at point P. So yesterday, not yesterday, on Sunday also we discussed that you have to first at a particular point find out the direction for magnetic field. So this point is lying, if you see, this point is lying on the axis of the first magnet. Let's say this is the first magnet, this is the second magnet. So from north to south it will move. So this is the direction, that is minus I cap. And this is the direction, right? So see, why towards minus I cap? Because axial line it is the same. And for north to south, see, this point is lying on the equatorial point of this. If this is lying on the equatorial point of this, the direction will be opposite to that. So from north to south, if is the direction, it will be from south to north, that is J cap. Clear? Why are we writing this? Is it clear to all of you? North to south is the direction. So for axial, it will be the same. So north to south, we have written minus I cap. But since second one is lying on the equatorial point of it, we are writing it as J cap from south to north. Now you just have to write down the magnitude for the axial and equatorial line. If we write out the first band, let's see, B net magnetic field. For the axial one, it is 2 mu naught m by 4 pi r cube. Just put minus I cap. That's it. Plus, for the second one, it's equatorial. So write minus mu naught m is a by 4 pi r cube. That is J cap. That's it. This is how you have to write. Write it down. One good derivation I have to tell you about torque. First, write it quickly. Then we'll discuss this torque thing. Class done? See, next question I wanted to discuss with you. See, show that, this is a good question, show that motion of a bar magnet in uniform magnetic field is in SHM. See, these are suppose magnetic field lines. So this is the bar magnet, north, south. Now torque will try to rotate it. There's a condition, if you all remember in class 11th, we have studied about SHM. So for linear motion, force has to be directly proportional to the displacement from the mean position. Right, so we have the formula F is equal to minus kx. If you remember, this is for the linear one. Torque is directly proportional to angular displacement. Torque is equal to minus k theta. This is rotational. All right. Now see, torque is equal to what? Torque is equal to M cross B, magnetic moment into magnetic field, right? M cross B. So this we can write as MB sine theta. Now small angle approximations are what? Small angle approximations. This basically means that if your angle is less than or equal to 15 degrees, it has to be less than or equal to 15 degrees. So tan theta is almost, or sine theta, both are almost equal to theta itself. So torque is equal to MB sine theta, where torque MB is fine, sine theta we can write it as theta. Now can you see torque is equal to K theta? This is the condition which we wanted to reach. K, this is the constant. This shows this, we wanted to find out this only, torque is equal to K theta minus sine means the direction. That is obviously there. So this shows bar magnet is in SHM. Even if you want, you can further find out that K is equal to MB. So angular frequency also, if there's a modification in this question, angular frequency is asked. So you can write omega is equal to K by I, where K is MB by I. I hope you know moment of inertia, magnetic moment, magnetic. From this, you can further find out frequency also. You can find out time period also, because omega is equal to 2 pi nu. So from this, you can find out frequency, and omega is equal to 2 pi by t. So from here, you can find out time period also, if further modifications of this question are given. Write it down and mark this question as important. In your theoretical questions, it can come in your 5 markers also. See, a magnetized needle of magnetic moment 4.8 into 10 to the power minus 2 joules per Tesla is placed at 30 degree with the direction of uniform magnetic field of magnitude 3 into 10 to the power minus 2 Tesla. Torque you have to tell. See, M is 4.8 into 10 to the power minus 2 joules per Tesla. Magnetic field is 3 into 10 to the power minus 2 Tesla. Theta is also given to us 30 degree. So torque is basically mb sine theta, which is 4.8 into 10 to the power minus 2, 3 into 10 to the power minus 2, and sine 30 half. So this will be 2.4. This is 7.2 into 10 to the power minus 4 Newton meter. This is the value of torque. Basic question just for revision for this. Now we'll come to the theory part. Quickly write down this question. Now we'll just discuss some terms related to magnetism, magnetizing field, magnetic induction and all. T class, there are some terms used to describe magnetism, like magnetizing field. What is meant by magnetizing field? Magnetizing field, basically, it's like if I have kept something in this will have a property, it will have a tendency to magnetize this material. All right, suppose magnetic field is there in vacuum. Fine. This will induce magnetism in a substance. Mostly this happens with solenoids also. So there we start using the expression B is equal to mu naught Ni, like this for solenoid. Then comes the term magnetic induction. This was magnetizing field. Then we have the term magnetic induction. Magnetic induction, this is basically magnetic force. This is basically magnetic force. See, number of field lines which are crossing per unit area. Normally, that is making an angle of 90 degree. So total number of magnetic field lines of force crossing per unit area normally is called magnetic induction. Few lines will also cross like this. You will not consider these lines. You will consider only these lines. Fine. This is what is meant by magnetic field, magnetic induction. Then you have a term magnetic field intensity. See class, these are very, very difficult terms, but meanings are totally different and meanings are very easy. You just have to remember the term. Here you are having magnetic field intensity. Next will be intensity of magnetization. So words will almost be same. Just remember their definition. Magnetic field intensity basically means ability to magnetize a material. All right, ability to magnetize a material. Here we represent it by the symbol H. H is equal to Ni. Means number of turns. If suppose a material is present, solenoid is present. So the number of turns which are present into the amount of current which is flowing. Fine, H is equal to Ni. So when we use the formula, no, P is equal to mu naught Ni. Here Ni can be written as H. Correct. This can be written as H. So we write B is equal to mu naught H. From here we have the formula for H. H is equal to B divided by mu naught. So magnetic intensity is equal to magnetic field intensity is equal to B divided by mu naught. And then we have the term intensity of magnetization. This basically means magnetic moment. See, words, I don't know why these terms are given, these words are made, but these are set now. We have to use these terms, but meanings are different. Just focus on the meaning. Magnetic moment per unit volume. We represent this also with capital M. Magnetic moment per unit volume is its formula. This is magnetic moment. This is volume. Fine. Magnetic moment is same, IA, and if n number of turns are there, that is NIA. Fine. Magnetization, whenever we use the term magnetization, see, whenever we use the term magnetization, remember one thing. We refer to pole strength. Ultimately, we talk about pole strength. See, total magnetic field is basically magnetic whenever we are talking about total magnetic field. This is magnetic field from the magnet, that is the magnetic field plus magnet intensity of magnetization, both magnetic field intensity. So we write this as mu naught M and we write this as mu naught H, the way we have seen. So one formula which you can remember, take mu naught common, magnetic dipole moment plus magnetic field intensity. This is also one relation which you can use. These questions do not come. This is not very important. But out of these, some are important, which I'll mention you. This one is important. this relation, magnetic field intensity. But anything can come in any ways. Do write down these four, get these four clear first, then I'll discuss the next four. Write down this first, understand this first. Terms, do not ask or do not go by this term, why this is magnetizing field, why this is magnetic induction and all. Meanings are different and meanings should be clear. Words, I am also telling you, words are misnomers. Repeatedly words are given, intensity of magnetization, magnetic field intensity, words are given like this. By convention, they are said by scientists, so we cannot change them also. See, now talking about magnetic permeability. So these four terms are clear to you. See, I know the names are a little difficult to remember, but I think content is easy. Just one line you have to remember for all. Clear or not? Then only I'll move forward. Aliza, Amna, Deborah, Fadil, Sidra,
Yes,
Rajita.
ma'am.
All right. Keep on saying yes or no at least, if not through mic, in the chat column at least. Okay. Magnetic permeability is very easy. Magnetic permeability we have discussed also right now. Magnetic in ratio of magnetic induction and magnetic intensity. This is what? It's just that when you have to learn these terms, it will be monotonous and boring because the headings are very same and common. But revise this thrice at least, then you will remember it. Magnetic intensity. Then relative permeability. Relative permeability is also easy to learn. Relative permeability is basically ratio of permeability in a medium to permeability of air, which is known as absolute. This is known as absolute permeability. This is permeability in a medium. This is only what we call as absolute permeability. This is known as permeability in air, which is 4 pi into 10 to the power minus 7. Then magnetic susceptibility is important, class. Please mark this as important. Magnetic susceptibility is actually important. This can separately also come, and this comes in the exam. Out of all these terms, other terms are not very important. See, magnetic susceptibility is ratio of intensity of magnetization and magnetizing field intensity. This was what? Intensity of magnetization. And this is magnetizing field intensity. Both these terms we have separately studied them. And SI unit, see, this has no unit. When we are talking about its SI unit, this is also ampere per meter square, and magnetic field intensity is also ampere per meter square. So basically this cancel, this has no unit. So this is a unitless quantity. All right. Now, why this is so important? Not because of this formula, because this has a relationship with permeability. How? See, B is equal to mu naught M plus H. This relation you have written in the fourth point. So B is equal to mu H also. Separately we have seen. Now put this in here. Mu H is equal to mu naught H plus M. Do one thing. If you divide this by H, divide by H. So mu H is equal to mu naught H plus M. This was there, divided by H. So this cancels, this cancels. So what is left? Mu is equal to mu naught 1 plus M by H. Class, what is M by H? Just now we have studied. That's chi M, chi M. This symbol is known as chi. So this is chi M, which is magnetic susceptibility. So this is basically mu is equal to mu naught 1 plus chi. This can be used as a formula for formula-based question also. And this question also comes to write the relationship between magnetic susceptibility and permeability. So that's why I'm saying this whole part is important. Quickly write it down. So terminologies are over. Write it down first, then I'll discuss the rest of the things. Class, on the group, I have shared a table. I don't know if you people have received or not. I'll share it once again. This has the difference between all the materials. So basic differences I'll discuss in the class, but everything properly is written in that table. So learn that table. Tomorrow I'll discuss it also, and only Earth's magnetism small portion is left. Tomorrow we'll start with EMI also. But before that, let us just discuss the few basic important points. So about diamagnetic substances, they have feeble magnetization. So feeble means weak magnetization. And that magnetization means the direction of this magnetization is opposite to the direction of magnetic field. Third point, feebly repelled by magnets means they are weakly repelled by magnets. They tend to move from areas of stronger magnetic field to areas of weaker magnetic field. These are the important points which you have to remember. Other points are also there. So examples are like copper, lead, silver. See, then you have paramagnetic substances. So paramagnetic substances also have feeble magnetization, that is weak magnetization. But how will you differentiate it from diamagnetic? They have feeble magnetization in same direction. This was in opposite direction. This is in same direction to magnetic field. They are weakly attracted by magnets. They are weakly repelled. Diamagnetic were weakly repelled. These are weakly attracted. Then they tend to move from weaker to stronger paths, opposite, like sodium chloride, copper chloride, aluminium, manganese, chromium, these. Then lastly, you have ferromagnetic substances. So they have strong magnetization. Firstly, this is the main difference, strong magnetization. And this is similar to this, same direction. But difference arises that strong magnetization. Feebly, see, first was feebly repelled, diamagnetic. Paramagnetic, feebly attracted. Right? This was paramagnetic was feebly attracted. Ferromagnetic you have here strongly attracted, and this is same tend to move from weaker to stronger parts. So iron, cobalt, nickel, all these alloys, these are examples. These are very basic points. This table, no class, there is nothing to understand in this. You have to remember this. You have to rote learn all these points. I'll share a table only right now on the group. All of you are connected on the group. Is there anyone who is not connected on the group? Because I'll reshare it on the group only. Just tell me, is anyone there who is not connected? Because then I'll share it on the group directly. Wait, let me share it itself. I think I have shared. But I don't know if you all were connected or not by that time. This is 23 to 24, right? So, yes. Just tell me, you have received it? Just someone confirm it.
Yes, ma'am.
Okay. 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 Good. Very good, Deborah. Received. Fine then. Please learn that table. These are just important basic points. No need to write this. This is just I have written so that I could discuss it with you. Something is written. No need to write this. Properly it's written on the table. All right. What I have to start with you all is the last. This is a very small topic, that is earth magnetism. This I wanted to discuss with you. A lot of time is not left. Just basic introduction I'll take. Then I'll leave you all because this is a very small portion. Just few slides are there. You have to remember. Gauss law in magnetism can come in your exam. Don't write that table point. That table is given. You can copy it down if you want. If you want, you can learn it from the picture itself. It's up to you. I'll prefer while learning, no, in learning manner, like we make notes, write down. So you will remember it also and you'll have it in your notebook also. But that depends how you study. Whatever way, whichever way is convenient to you. See, electric field in Gauss theorem, we had seen that closed integral of E dot ds was equal to enclosed charge by epsilon naught. All those who are new, no, who have joined it later, like I think most of some of you who are present right now, they have joined it later also. Don't worry about the chapters that have been missed, though I know you all know those, but once we are thorough with the syllabus, no, see, few chapters are left in this. You have We have to discuss EMI, AC, EM waves. These are short lessons. Meanwhile, your ray optics will be over by next week. Wave optics will be started by next week. So second book is also going. So syllabus will be completed in December. So you have revision classes also. There we'll complete each and every chapter. All right. So this we had seen in electrostatics. Fine. About charges. In magnetism, closed integral of B dot ds is 0. All right, this is known as the surface integral. This is what you have to remember, Gauss law in magnetism, that this is ultimately 0. This wasn't 0, but Gauss law in magnetism is 0. So few points you have to remember. What are the consequences of Gauss law? Firstly, this we have discussed it so many times, that isolated magnetic poles do not exist. North will exist with north, south will exist with south, or north and south will exist with each other. You don't have separate charges like you have electric charge plus q minus q, protons, electrons existing, right class? Magnetic monopoles always exist, unlike pairs, right? Unlike pairs. They are of equal strength. This means we are talking about north south only. Equal strength, we are talking about north south pole only. And number of field lines which are entering, these are equal to number of field lines which are leaving. So if 4 lines are entering, 4 lines will leave. So number of field lines entering is equal to number of field lines leaving. Magnetic field is produced only by magnetic dipole because magnetic monopoles do not exist. Means this is formed by set of dipole only. That's it, what you have to remember. All right, now just earth magnetism, one point I'll discuss it later, tomorrow only. But these few points about Gauss theorem, because you already know Gauss theorem, you just have to remember that magnetic flux in Gauss theorem is 0. So the Gauss law in magnetism states that surface integral of magnetic field is 0. That's it. If I note down these points, then earth magnetism proper points I'll discuss tomorrow. It will take 10 minutes tomorrow. Write this down first. If you have completed till here, you can leave. Tomorrow we'll just complete that Earth's magnetism part. 5 to 10 minutes it will take. Okay, thank you so much. No, Devora, no assessment for today.